So permutation is an ordered arrangement of all or some of the members of a set. We did arrangements of all items the other day. Now we're going to focus in on smaller numbers of items from a bigger set. Okay? So, review here, back to the other day, use the fundamental counting principle to determine the number of permutations of the letters in the word logarithm. If all the letters are used without repetition, and the permutations must begin with an L. Now here, we don't actually have to say this in this question, okay, because those are the letters. It's different than digits, where you're not, you just have digits, 0 through 9, and you can see them. Those are the letters. So consider those like Scrabble cards. Does anyone play Scrabble before? See the Scrabble game? Each letter is on a tile. So this is saying that you have one of each of those. So sometimes we're not going to say that, okay? Because it's understood. You only have one L. You only have one O. You only have one G. Okay, so you don't have more of them. In any case, count up how many you have. 3, 6, 9. Okay, and it must begin with an L. So there's just one L. So one option for that, no other choices. So we use one letter up out of the 9, and now we have to arrange all the other ones, which will be 8 factorial. Okay? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? Because it says the number of permutations of all the letters. Okay? So it's not saying only 3 of them or something like that. I'm not going to find the value, just leave it like that. It's 8 factorial. Begin and end with a vowel. Okay, so how many vowels are there? O, A, I. There's 3 vowels. So to start, we have a choice of 3 vowels. We've used one up, so now we have a choice of 2 for the end. It does not say, guys, it does not say exactly one vowel, so the next one can be vowel or not, right, because there's 3 vowels. So we've got our arrangements of the beginning and ending letters, and we have to fill in, right? There's 9, we've used 2, so that's 7 left. This one you could show as 3 factorial, 7 factorial. So 3 times 2 is the same as 3 factorial. Okay, again, I'm not going to enter it and find the number. Now, must have the vowels together. So we talked about this yesterday, or the day before. I often start with the vowels together at the beginning. So there's 3 vowels, so there's 3 factorial to get the vowels together at the beginning. And then I would have 1, 2, 3, 4, 5, 6 remaining letters, right? All the consonants afterwards. So these are the consonants, okay? Now, saying that, so that would be 6 factorial. That would be the answer if the vowels were together at the beginning. But this just says they have to be together. So remember, we have to arrange all of these. These vowels could be there. They could be after the first consonant, after the second, after the third, all of those. So where can they be? That's 1 arrangement, 2 arrangements, 3, 4, 5, 6, 7. So there's 7 ways we could put that grouping of vowels in there. So we multiply by 7. And so really, as a fast way of calculating that, that's 3 factorial, 7 factorial. So anytime you're grouping objects together and then arranging everything, it's the arrangements of those in the group. And then consider that to be 1 object and the remaining 6 here. So really, we're organizing 7 objects. Okay, 7 factorial. no two vowels are together. So yesterday, we did some questions where we used the complement, so the total minus. Why can't I do it in this one? Why can't I go total minus the answer is C?
This one is no two vowels are together. That one was R with the vowels are together. So it doesn't make sense.
It's not the same thing. You might think of it, but in this groupings, all of these, that's where we had three together. Okay, that means it doesn't include those that we have two and one, right? Two and one left over, and this is saying that we can't have any of those. So by subtracting, that's not going to get us the correct answer. If there were only two vowels to start, and we calculated vowels together, and this one, vowels not together, then yeah, we can do the complement, but we can't in this case. And you'll notice there's a little note on the in Schoology for the solutions to this, that it's not this, the answer that we have there is not for this particular question. So in any case, no two vowels together. Think about, we've got 3 vowels and 6 consonants. So I like to think about writing out the vowels here, okay? And so obviously 3, 2, 1 for those arrangements. But got to have them split up here, right? Now we have 6 consonants, but we have to make sure that for sure they go in between here, right? And they can go at the end as well. Okay, so you've got to think about it. It's a little bit like yesterday's. So you want to consider how many places around those vowels you could put a letter. Okay. So before, between, or after. So, and then think about how many letters left. So we have 7 letters that we, 6 that we need to put in between, arrange for that. So that's 3 times 2 times 1, and then we have 6 that we have to arrange. Oh, you haven't learned permutation. So, you have 6. So I'm going to put it here so you can see it, because it's actually easier with permutation. So 6, yeah, actually, now that I'm looking at that, this gets a little bit harder to explain it without permutations.
Guess what we're coming back to?
Yeah, we're going to come back to that after we learn permutations, because there's another question. So stay tuned on that one, and then it's a lot easier.
Okay. Fundamental calculus. Oh, that's what that is.
Okay, so just stay tuned on that one, because then it's easier when you come back after we learn a little bit more. Okay? Okay, so now getting into group of objects, but now we're only taking a certain number of them. So we've got the word factors, the letters in the word factors, right? When we're doing these arrangements, the arrangements we get aren't necessarily words in the English language, right? They're arrangements. So don't start thinking about do the letters make sense. So we only want 3 letters. So if I show here 3 letters, count up the number of letters, that's 7. So think about for a 3-letter word, we have 7 possibilities for the first one. We've used 1 up, 6. Now we've used 2 up, 5. So that is the number of arrangements, possible arrangements of 3 letters out of those 7. So what's that? 210. You can do that in your head. So 5, 2, 3, 4, 5. We have 7, 6, 5, 4, 3. So what's that? That's 210 times 12 further. So, 2,520. I think I did that right. Okay, represent using factorials. Well, I can't say, like, this is not equal to 7 factorial, right? 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So using factorials, if I wrote that down, what would I need to divide by? 4 factorial. Okay, so that's for A. Here, this would be 7 factorial, but then what would I divide by? 2 factorial. Okay, or 2. But let's think about factorials, because that's what's going to work for all of them. So, this is the notation that I was getting at before, right? That's new for you. So the number of permutations of n objects taken r at a time can be determined by, so what did we do here? This was 7 objects, so that's n. And how did we get, here we had 3 letters, we got 4 factorial. Here we had 5 letters, we had 2 factorial. So how do we get this factorial in the denominator? In terms of n and r. Is it r factorial? No. What is it then?
N minus r factorial?
It's n minus r. It's the difference, right? So 7 minus 3 is 4 factorial. 7 minus 5 is 2 factorial. So this is n over n minus r factorial. Okay? That's how we can show that in factorial form. And that's the definition of this P notation, permutation notation. NPR is n factorial over n minus r factorial. Okay? So what that says is, and for you guys in IB, remember we use whole numbers, we use natural, but anyway. Okay, so here, n is, in the first one is 7. So that's 7 factorial. We're arranging 3 objects. So that would be, so this would be 7p3 to give us this. Now, in this case, it's way easier in your calculator to do 7, well, you can do that in your head. You don't need a calculator. In your calculator, where do you find it? So same place that you find factorial. So you go math P. Okay, so there are your calculators. Then probability. And it's the second one down. Okay? Now, if you have a newer version that has the ability to show it as a subscript, then it will flash on that first number, so that would be 7. Cursor to the right, 3. If you have an older version, put in the 7 first. So 7, then go math, probability, NPR, and it will show it if you have an older version of the calculator. It will show 7, and then NPR, and then you enter in this case 3, and it will give you the same answer. Okay. So just remember that NPR is not n factorial over r factorial. Okay, it's the difference. Right? So that's going to end up being, make things a little bit faster for you in some of your questions. So in example 4 here, I want you to evaluate. Some of them try not using a calculator. Like back in the day when I was in school.
And like us, you want some?
Yeah, it might not be factorials in the calculus, so.
I mean, the definition, yeah, I'm not going to go there.
So, for example, 10 factorial, if you think about it, could be shown like that. So I know I can divide out the 6 factorial. I know 4 times 2 is 8. And 3 goes into 9 3 times. Voila, no calculator needed. What's that? You said it was crap?
No, it's witchcraft.
Oh, witchcraft.
Oh my God.
Oh, it's math logic. Okay, in your calculator, sometimes it won't accept a really big factorial, so that's why you want to be able to simplify. But in your calculator, if you have a newer version, I would actually use the fraction form, so you don't have to use brackets. And then you go 10. This is why it's kind of a hassle, right? Like if you can do it in your head, go for it. And then denominator 6.
Oh, wow.
4, hopefully you remember, is 24. Okay, so you get that. Now, if you have an older version that doesn't have the fraction capability, then you have to go 10 and factorial and then use brackets. Right, so then you go divide bracket 6 factorial. And then again, I know that 4 factorial is 24, I should probably know 6 factorial. Okay, make sure you enter it correctly in your calculator. Okay, so evaluate 8P5, try it in your calculator. Or,
Hey, the first one, that's just the product of the first 4 times. Sometimes 5, sometimes even 6. The first one. Yeah, no, yeah, just 2 things. Which you can represent using the...
okay, so the next one, oh, what am I doing? Sorry, that's wrong. Okay, so that's 8 factorial over 3 factorial, right? Because 8 minus 5 is 3. So that would be 8 times 7 times 6 times 5 times 4. Or do it in your calculator. Usually I will do it in my calculator unless these two numbers are close, because then you know you only have a couple factors in the numerator, right? Okay, next one. Think about algebraic skills and factoring, right? So 15 factorial is, and so we're going 15 factorial minus 13 factorial, and we want to try to show that it's equal to 209, no factorial, it's 209 times 13 factorial. So 13 factorial is in this one. It's not shown there, but it is a factor of it, right? 15 factorial is 15 times 14 times 13 factorial. So this is my left side. Okay, so now if I factor out 13 factorial, I'm left with 15 times 14, which is 200. Okay, so you factor it out, and then 210 minus 1 is 209. Okay, then a little bit of the algebraic skills indeed. So obviously, you can use trial and error with your calculator to get n. But if we asked you for algebraically determined, And you need to think about what NP2 is. So that's n factorial over n minus 2 factorial.
By the way, the maximum factorial that your calculator can compute is 69 factorial.
We're only using whole number.
Yeah, we're not going to the down. I'm talking about whole numbers, like just pure factorial.
Okay, all right. Let's get back to this. Okay, so here, think about, you cannot show n factorial the long way. You don't have every single term in there. You don't know what n is. Okay, so if you're algebraically determining this, think about back what I did up here. I divided out common factors. So n factorial is the same as n times n minus 1 times n minus 2 factorial over n minus 2 factorial. Okay, so just showed a few factors, and now those divide out. So I really have n squared minus n equals 56, and that is a quadratic that you can factor. Okay, and if you can't factor it, then you did something wrong, because n is going to be a natural number. Can't be negative, so you would choose any positive solutions to that. This was in a multiple choice and numeric response, then just use your calculator. Draw an arrow.
Just try that.
Yeah, especially if it's small, it's not going to be relevant.
Oh, hey, if you take the absolute value, the two n values, multiply together, get 56.
This okay, when I talk to the negative,
Can't have a negative number on it.
Just try the calculator, see, it'll screen it.
Okay, so next one here, same type. Now we're starting with n plus 2 factorial over n plus 2 minus 2, which is n factorial. So now, when you don't have to show this step, but you can break up the numerator into some factors so that you can see that division. If you know right away that the factors left over are n plus 2 times n plus 1, then that's fine as well. But those are going to divide out. So if the numerator and denominator are 2 numbers apart, then there'll be 2 factors left in the numerator. If they're 3 apart, there'll be 3 factors. 4 apart, there'll be 4 factors. Okay, because it's factorial. You almost finished with your chips? Up there? So 180, so 10 and 18 doesn't work. 15 and 12 works. And again, how do you check? You put 12 back in, so that would be 14 P2. So 14 math P2. 182. Okay, so I'm going to just leave the next one for you to do. The only thing here to start, I would divide by 2. Okay? That might end up being, notice how the difference is 3 between these. Numerator and denominator. So you might have something that is even 3. Okay? So just be aware, you've learned all about that a number of times. Okay? So I'll leave that for you to do. Okay, so let's take a look. What's the value of 0 factorial? So let's go through this process here. So it says, use the fundamental counting principle to determine the number of permutations of n different objects if all n of the objects are used in each permutation. Right? So that is just n times n minus 1 times n minus 2 all the way down to 2 times 1, right? It's n factorial. Okay? We did that. We did that the other day. We didn't need to know notation. We knew that arranging all of the objects will be that factorial, however many objects you have. Okay? So, now that we've learned our permutation notation, we have n objects to start, and we are arranging all n of them. So we just said this will be n factorial. Okay? Well, what happens when we look at the formula for NPR, if these are both n, then we have to replace that r with n. So here, we'll have n factorial over n minus n factorial, which is 0 factorial. Okay. We know NPN has to equal n factorial, so that means that those have to be, that has to be true. So that means that n factorial is equal to n factorial over 0 factorial. So 0 factorial is plus. So it's a weird thing. Normally we cannot divide by 0. But we're not dividing by 0, we're dividing by 0 factorial. Okay? And there's more explanations. I can't give it to you, so you can research that on your own. This is the explanation at this level. Okay, so based on this, 0 factorial is 1. Okay. So, we've already done this. Okay? This you can do on your own. That's just in your calculator. We've already done that. I did it a little bit different order. Okay, so permutations with restrictions. So we've already actually done some of these types as well. You have to start with an L, or have something in the middle, or exactly 2 consonants, and blah, blah, blah. Those are restrictions. Okay, but now we're doing them with maybe a smaller group of the objects. Okay, so here it says determine the number of ways the executive committee consisting of a president, vice president, secretary, and treasurer can be selected from a student council consisting of 15 students. Okay, so we have 15 students in this group. We have to figure out all the possible ways of assigning them a duty. Okay, so for positions, I'll help you with the window in a second. That's why I don't open the window. Okay, so for positions, and you have 15 people, then 14, then 13, then 12. Okay? Do you have to necessarily show it that way? No. 15 people for positions, so 15 through 4. Okay, we're just going to leave it. We're not going to bother having the number right now. Okay? So this would be, I don't know, president, vice president, secretary, treasurer. So 1, 2, 3, 4, treasurer has to be Jerry. There's only one Jerry. We don't have multiple people. Even twins are not the same person. Right? Okay, so there's one Jerry. And then we use one of the 15 people up. So we have 14, 13, 12. So this is really the arrangements of Jerry, 1P1 if you want to show it. You don't have to. And then 14 arranging 3 of them. Okay. So again, I'm just going to leave it in that. You can calculate the actual number. A lot of times, like for example, on the diploma exam, this was, or a test or whatever, if it was in numeric response, a lot of these numbers are too big to go into the numeric response. So they might say, show it in the form A, P, B, and then enter A in the first box, B in the second box, or something, or A plus B. Yeah, exactly. Okay, Melissa must be either president or vice president. So, if this is president and that's Melissa, then there's 1. And then again, say like Jerry, 14, 13, 12. Now, then it's VP. Okay, and then it's 14, 13, 12. So really, it's 2 times 14 P3.
Oh, that makes sense. That's a nice
You can
part.
put the 1P1, but you don't have to.
The nice part about common points is that if you look at these stuff, you can literally reinforce it. Sometimes, if the number is small.
Well, very rarely. Some big numbers.
Yeah.
Find a smaller situation. We're going to do that. Okay, so then, license plates for a particular state consists of 2 letters followed by 5 digits. So these are letters, and these are digits. Okay? Determine the number of license plates that have no repeating letters or digits. So this happened, like this, basically, when I was young, it was always 3, 6 in total, right? And it alternated letters and numbers. And then they had to introduce another, so that, because they needed more license plates. Because it's not one person might have more than one vehicle. And once that license plate is used, you keep it unless, I think if you hand it in, they wait a certain number of years and then they will reassign that license plate. In any case, they were running out. Same with area codes for phone numbers.
I believe that's also why they started, like, lowering the prices for custom license plates, because it makes that issue a lot less.
Maybe.
An issue.
Yeah. Okay, so letters in the alphabet, how many? Everyone knows there's 26 letters in the alphabet. Okay, and it says no repeating letters or digits. That question, we do need to know that, right? Okay, because it's not saying this particular word made up of those letters. It's saying they're made up of letters. So we have to be told that there's no repeating letters or digits. If there were repeats, this would be 26 and 26. Okay? And then no repeating digits. Again, you can start with a 0 here. 0 can be anywhere. It is a digit. There's no restrictions on that. So there's 10 digits. So 10, 9, 8, 7, 6. That's the long way. So in terms of P notation, that would be 26 P2 times 10 P5. And you can do that on your own. get on a bus with 12 available seats. Determine the number of different arrangements of the 5 people if all take a seat on the bus. So sometimes you get a little bit confused when you think about it. We're not arranging we've got 5 people, so normally we're arranging the 5 people, but we have 12 places to put them. So we're not saying the 5 people and arranging 5 factorial. We've got 12 places, so we're really arranging the 12 seats with those 5 people. Okay, so here, 12 seats available. Those are your objects that you have to arrange with those 5 people. Okay, so normally we arrange the people, now we're arranging the chairs, basically, right? Well, yeah, you can't. If you think about permutations, as it is, you can't do 5 to 12. So in a way, that's a way to check, right? Yep.
What feels like 12 feet for 12 feet? That is equal to 1.
No.
So then it's like, add
Because
minus
you're arranging the people in that order to 12 factorial.
12 factorial over 12 minus 1.
yeah, 12 minus 12.
So yeah, 12
Which is
seats and
0
12
factorial.
people. You can
12
sit the
factorial.
first one or the last or the middle and all that kind of stuff. Yeah.
Yeah.
12 to 12, which is 12 factorial. Yeah. Okay, so the next one, determine the number of permutations that can be made using 5 letters from equation. Okay, so count up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, but we're only doing 5 letters. Okay? And there are some restrictions. So I do like to write it out myself. It has to begin with an E. Okay? So it has to equal E here, so there's only one E. So then you're left with 7 choices for the next. 6, 5, 4. 4, you can show that as 7 E 4. You can go 1 P1, 7 P4. You can go to 7 P4. 1.
Yeah.
Okay, so there's 3 consonants. Says it must begin and end with a consonant. Okay, it doesn't say exactly. So all we are concerned about are these. So 3 consonants. That's the choice of what to start with. Use 1 up. So then 2 left for that. Now we've used up 2 out of the 8. So we have 6 left to arrange in 3 words. Okay, so next one, it has to contain an O. Because remember, we're only doing a 5-letter arrangement. So it could happen that of these, if you did all the 5-letter arrangements, 8P5, some of them might not have an O. We want to make sure it has an O. So I'm going to start and say, okay, the first letter has to be an O, the first letter. So then that's one possibility. right? There's only one way to do that. And then 7, 6, 5, 4. So 7P4.
So wouldn't that be 5 times 7?
And then, exactly. So as Ali said, then 5 times that. Because then you could have the over here, or here, or here, or here. So it's going to be this times 5. So just write it out there.
You must think about it as like, you got like 5 spots, but you only got one thing, so 5P1, which is 5.
Yeah, yep, you can do 5P1, exactly.
This is
5 places, 5 spots for that O to go into.
So this is like one of those cases, once again, where you got to be very distinctive with where the numbers are. Yeah.
Okay. And then it says contains the letters T-I-O-N in that order. Okay, so I just write, so 1, 2, 3, 4. So this has the T-I-O-N. So there's only one way to do all of those. Yep.
This is on order responsibility. You should write 1, 2, 1.
No. Yeah. You don't. 1 to 1, you don't get. So T-I-O-N has to be in that order. There's only one way for putting those down. So next thing, it has to be a 5-letter word or arrangement. So we only have one more spot to put in, right? One more letter. It could go at the beginning, or it could go between, or there, or there, or there. Okay? How many letters do we have that have to go in between them? How many possible letters? 4. Right? Because T-I-O-N used 4. So 8 minus 4 is 4 letters that could go in here. Okay? So we have 5 places to arrange those 4 letters. Okay? So that's going to be, that's too many. Because there's only one letter that can go in there.
So you'd have to
Right?
do like a 5, 6.
Let me explain. So there's 4 letters, there's only one letter that can go in. So this would be for example, E could go there, or there, or there, or there, or there. That's 5 options for E. Then for Q, 5 options. For U, 5 options. For A, 5 options. So how many was that? 20. Okay. Everyone get that? So in this case, I'd probably just say, okay, 5 places, and there's 4 letters that can go in there. Okay, because I would end up using P-notation. Talking nonsense. Okay? So this one, you can actually think about it case by case. Because it's only one letter that we have to fill in to get a 5-letter arrangement. Right? You can do this a long way if you need to. So it could be an E in any of those positions, a Q in any of those, a U, or an A, and that's it. So 20 possible arrangements for that one.
So what's the same as 4 times 5 p.m.?
4P1 times 5P1 times 1P1.
Just like
4 letters.
question?
Would it be like 20? Would it be the same as like 4 times 5 P1? If it's 1 letter, if it's 5 spots, and there's 4 letters.
4 times 5 P1.
Yeah.
No, that's a big. That's 5 factorial over, oh yeah, I guess it is. Yeah, if we wanted to do that. Yeah, 4 letters, and these are your places that you're choosing one. Yep. Yeah, that's a good way of looking at it. I just kind of think about it the other way. Yep. Okay, next one. Final score in a baseball game. You do not need to know how to play a baseball game to answer this question. I get that every year. Okay? I don't know how to play baseball. I don't know how many innings. I don't know. You don't need to know. Okay? It says the final score was 8-5. Determine the number of different scores that were possible after the 4th inning. Okay? You don't have to know how many innings. Okay? What does any game start out as a score? 0-0. Could the score be 0-0 after a certain inning? Yeah, no one scored anything. Okay? Doesn't matter how many innings, they're going to could go from 0-0 to 8-5 at the end. Again, you don't have to know how many innings. Okay, so final score was 8-5. How many possible after the 4th inning? Because we have to think of all possible scenarios. It could, after the 4th inning, still be at 0-0. Okay, so you could start at 0-0. You could start at 0-1, 0-2, etc. What would be the maximum that the second team could have in the 4th inning? 5. They can't score.
Like 8 plus
They don't
5.
get scores taken
8 plus
away.
I don't know what game you're playing.
They don't get scores taken away. That you do have to know. But I don't think any game does. Then for the other team, could be 0-8, right? They could, after the 4th inning, have a score of 8-5, and then no one scored anything more before the end. Okay? So, how many possible scores for the first team? 8? 9. Include the 0. No. Then for the second team, 6 possible. So 8 possible for the first, 6 possible for the second. Oh gosh, what am I doing? Now I'm getting messed up. Sorry, 9 times 6. Okay? So you could have 9 P 1. No, what am I doing? We'll just leave it 9. Don't use please. 9 possible scores. So for each of these, a tree diagram. Do a tree diagram if you need to. For a score of 0, you could have had a score of 0, 1, all the way down to 5. For each of these 9, you have 6 here. So 9 times 6 is 54. Again, you could do a smaller version of it if you needed to. Right? But it's just a tree diagram. For each of this, as your first score, what's your possible second score? 0 through 5. So there's 9 possible first scores. For each of those, there's 6 possible second scores. 9 times 6 is 54. Okay, we are
Oh, should we go back to that other question?
Not yet. I just wanted to something here before I go back to it. Okay, so question 12. A photo of the 4 men and 5 women of the math department is to be taken for the yearbook. Determine the number of different versions of the photo. If members are to be arranged in 2 rows, 5 positions in the front row, 4 positions in the back row, no other restrictions. Doesn't matter that there's a front row and a back row.
Not yet.
When you're lining up. So if we had 9 people, and I had an arrangement of 5 and then 4, so 9 people, and I said, okay, you 4 move behind, that's still that same arrangement. So just because they're maybe moved in a different physical place, doesn't change the fact that you're arranging 9 people. Okay? So this is 9P9. Now, in the next one, 4 men must be in the back row. So, again, that doesn't have to be in the back row. It could be at the end of your line. But you do have to keep those 4 people together, those 4 men. So you have to arrange them. And then all the arrangements of the women. So that's split up. Just happens that they might be behind. They could be in a row. Saying that, if they were in a row and the men must be together, then there's those options that they could be in between. But in the back row, that's one particular place. So that would be, so this being the men, and this being the women. So then this one, I need to be in the front and center, of course. Not really, I don't like the front and center, but in any case, there's only one of me, all right?
That we know.
That we know of, yep, only one. I haven't been cloned. So there are 8 remaining people. Doesn't matter where they are, right? Front or back, doesn't have to be women in the front or anything. So it's going to be 1P1 for me, which you don't have to show, and the remaining 8 people have to be arranged. So it's factorial. Okay. Okay, so on that note, so the next question 13, I'm actually going to leave question 13 because we did ones a little bit similar yesterday or the other day with all digits. Now we're just giving you a certain set of digits to use. Okay? 0, 1, 2, 3, 5, and 7. Just those. Alright? So I'm going to leave that for you to do. And it's a 3-digit number. Okay? So those, because you've seen some of those before, we have a lot to get through. So I want to try to make sure that we're already here. So then let's go to number 14. I think this came from an old diploma. So 10 acrobats were stacked themselves into a human pyramid. Bottom row has 4, next has 3, etc. The number of different human pyramids that can be formed is. So this would be thinking that each row is sort of different. I don't know how to say that, but that physically those rows are separated. But remember, if you have, this is kind of like the math department photo. We had 5 and 4, all the arrangements, it didn't matter. It was still 9 factorial. So how many different pyramids? If we have 10, just make sure 4 in the front row, 3 in the next 2, and 1. That adds up to 10, so it's going to be 10 factorial. Okay? A lot of people will say this. And there might be some cases where it might be that, something similar to that. Some might do this because it looks kind of like a pyramid. Not sure, I guess 10 factorial, 4 factorial, no zero, division is 4. So questions like that are actually fairly simple, but they do trick people a little bit. And this one's good. Numeric response question on a test. Okay? Answers to a numeric response question is comprised of 4 digits. So this particular possible, we could have 4 digits, which is 4 boxes. And remember that so you can have an answer of 0 by itself, right? This says every box has to be filled up. Okay? Think about some of the numeric response questions that we've given. Sometimes we'll say the code is, say, 0 or 1 or 2, and you have to fill in the code number. It's not necessarily representing an actual numeric answer to something. So we just have to assume here is what I'm trying to say is that you could have 0 in each position, and that be a correct answer. Okay? If it was some kind of question like that. So maybe the code was 0 for some particular answer, and every question has that answer. So you put 0 in decimals. We're only going to do digits for this.
Okay, so like that really complicated.
Yeah, because decimals only go into these 2. In any case, so how many possible for the first one? 10. How many for the second? 9.
Actually, there was, oh yeah, so, right, no.
You have an answer of 0, 0. I just went through that. 0, 0, 0, 1, 1, 1, 1, etc. Okay? Now, I don't see 10,000 there as an answer. I don't see 10 to the 4th. But, okay, first of all, you can enter these all in your calculator and find which one matches. Or, remember, we want 10P1 is going to be 10 when you evaluate that. 10 factorial over 9 factorial is 10 to the 4th.
If it was P1 it'd be. That didn't say about 10 P's 4.
That's for different.
How do you say that?
I might just say 10 P4 or 10 permutations. You say 4 permutations of 10 permutations. Okay.
The answer is
10P1 has a value of 10.
okay.
Anyways, it's 24. Right? There's 10 digits, and you're arranging 1 in that box. Each box. Okay. Next is when we might have identical objects. So in a word that's given to you, maybe there's 2 T's or 2 M's or something like that. That's going to cut down our number of different permutations. Okay, because an M is the same as an M. So let's take a look at this particular example, because this will actually lead into pathway problems, the practice sheet afterwards. So this is an application of identical repetitions. So it says Johnny walks to school from home along the grid line shown in the diagram below. The school is 2 blocks north and 3 blocks west of his home. So he's starting here and going there. If Johnny must stay on the streets as represented by the grid lines and always move closer to school. So he's not going to go a block and then come back home, and then go 2 blocks and come back home. That would mean there's an infinite number of ways for him to get to school, because he'd be going back and forwards and backwards forever. Okay, so he's always either going up or going to the left. Determine the number of different routes you can take to school by tracing. So we're doing it the long way. We call it brute force. So if you have different colors, you can do that, but try to find the different routes that you could take. Just trace them on your diagram. You count up as you go. Right? Always getting closer. What did you guys, who has some numbers? How many routes? 10. Sounds good?
64.
What?
You were going back and forth and around and about.
No.
You got 64 in that little bit of time, you found 64 ways?
Well, like, kind of like the different intersect, like the ways, like at each intersection, how many, the number of routes, and I just walk them right on.
Yeah, but that includes like going backwards or down.
But then, like, I eliminated going backwards.
Too much.
Wait, is that 5 now?
It's 10.
Is it?
So, long way to keep track without actually doing the routes is, okay, to get to this corner, and I think, Eric, you were trying to do something similar. To get to this corner, there's one way to get there, and one way to get to that corner, right? To get up here, there's still just one way to get there. Still just one way to get to each corner along each side, okay? So to get to this corner here, we can go from below or from the right. So there's 2 ways to get to that corner, okay? So if we just had a square like that, there's 2 ways to go from home to school, if that was our diagram. If it was just this part, home to school, well, you can go get there this route. So from this side, there's 1, but from here, there's 2. So there would be 3 ways, right? So up this way, and this one. Notice how this 3 is 2 from there and 1 from there, from the previous corners of the block. Okay? So, over at this one, because you have to get here from the right or from below. You can't come from above, right? So from here, the only way from below is just one way to get there. From the right, there's 2 ways to get here, so that's the same. So 1 plus 2 is 3 ways to get to that city block. Because really, it's 2 little squares. This was 2 squares. Just one's vertical, one's horizontal. Okay, so we're getting closer. Now up here, to get it to this, well, to get to this city block, we have to have come from here. There are 3 ways to get there. Have to come from here. There are 3 ways to get there. So there's 6 in total for that one. Okay. So the school was here. There would be 6 ways to get there. Then the last part of it, to get to this corner, there's only 1 way to get from below, 3 from the right. So there's 4 in total. And then to get to school here, only way from below is 4 ways to get there, 6 ways to get there, which is 10. Those numbers are going to kind of show up for us later, in the next week or whatever, if you've heard of Pascal's triangle. So those are numbers that are in Pascal's triangle. Okay? In any case, there are 10 ways. Don't want to always have to do it the long way. So that's what we're going to try to come up with here. Yep.
You do like, when I got 64, could I just add the digits in PDF? Is that a balanced way?
You'd have to prove that the digital root was somehow valid.
Well, it matches with this, so.
Well, try it for a different one. I don't think it'll work. So
You can prove that it's always like the number of total possible versus the, well, you have to divide, you have to find
we're not doing the Jackson. No. So what is the total number of blocks that Jackson walked to get to school? So any of the routes that he takes, that you were drawing, how many blocks did he walk? Not the distance, just how many blocks. So if he took this route, 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks. If he went 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks. 1 block, 2 blocks, 3 blocks, 4 blocks, 5 blocks. What am I saying? 5. Okay? So total number of blocks he has to walk is 5. Notice how if we were to write out the routes. So from home to school, he's either going north or west. So this route is north 1 block, west 1 block, north, and 2 west. Okay, that's that particular one. Write out 2 other possible routes. So maybe, make it easy. 3 wests and 2 norths. Okay. How about the other? 2 norths and 3 wests. Okay, if he needs to get from home to school, he can't skip a block, right? He cannot go either. Just jump over, fly, or whatever. Okay, so he has to go 3 W's and 2 norths, always. So what will all the routes have in common when they are written out using the direction of travel? They will all have 3 W's and 2 norths. Okay, so I want you to find the value of 5 factorial over 2 factorial, 3 factorial. What did you let challenge yourself? Because you don't have to really do it. Divide out some factorials. we get? 10. Okay, so how does this compare? It's the same. Same value. Okay, so how can we get this? So if you consider doing this pathway as using letters for the direction and thinking about those letters and arranging them, we have 5 letters that we have to arrange. 5 factorial. You can go 5 and 5. But we end up dividing by 2 factorial, 3 factorial. Why do you think we divide by 2 factorial and 3 factorial? What's significant about those numbers? And the letters. Right. There's the length and the width. And so in terms of the letters, they are what we have in this case. The width is west. It can be east if you're going from the left or whatever. But the dimension is 3, so we have 3 of those letters. And they're repeated. So when you interchange a W with a W, it looks the same. This 5 factorial assumes all of those objects are different. Okay? So we got to get rid of the ones that are going to be repeated because those letters are the same. So 5 factorial is the arrangement of 5 objects or 5 directions. And 2 factorial is the arrangement of the 2 repeated north. And 3 is the 3 repeated west. And we want to divide out to get rid of them. Okay, so 5 comes from the dimension, the length plus the width. 2 is the width, I guess you consider in this case, and 3 is the length. Okay, the repeated objects have to be taken out of the answer. Why is that? Okay, so taking a look at this next one here, it says Johnny travels 20 blocks south and 8 blocks west. So 20 blocks and 8 blocks west. If he stays on the street and always moving closer to his friend's house, so you can draw a rectangle like that, determine the number of different routes. So this dimension, this would be 20 S's if we did each block being an S in the south direction, and it would be 8 W's. So in total, it would be 28 blocks or letters that we have to arrange, but there's a whole bunch of repeats. 8 are west and 20 are south. That would be the number of arrangements, or number of pathways. Alright, so that summary box on the top right says a set of n objects with A identical objects of one kind, B identical of another, C of another. This would be many different identical objects. In this particular case, it would be n factorial over A factorial, B factorial, C factorial. And you could always show that as n, p, n if we wanted to. So we divide out by the repeats. If you wanted to spend some time, if you don't trust this, then I would say choose something small, say like the letters now. The arrangements of those letters is 4 factorial. Okay? Then if you decide, so write them all out. Then change it to say, oh, let's make this MMTH. So everywhere in all of your arrangements, cross out the A's and put an M. And then see how many are actually different. Okay? You would actually have half as many. And then you could replace all the T's with M and see how many. So you can do that on your own time if you want to see how that math works, but do it with something small. This one is a big word, right? Mathematics, so count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice that there's repeats. So M repeats, A repeats, T repeats, and that's it. Okay? So we're using all of the letters. And for these questions with repeats, we will always use all the letters. It gets complicated if there's repeats and you're not using all of them. In any case. So in this, normally if they are all different letters, it would be 11 factorial. But now we have repeats. So we're going to divide by 2 factorial for the M's, 2 factorial for the A's, and 2 factorial for the T's. We're just going to leave it like that. You can figure out the actual number if you want. Okay, so this one, I'll show you how I do it. It's kind of 2 ways of doing it. So we have to have an M at the beginning and an M at the end. And there's 2 M's in total to choose from, right? So the way I think about it is, okay, I've got to have an M. I have 2 M's to start, and then 1 left over to put there. Now, M's are the same, so I'm going to end up dividing by 2 factorial for the M's. So in essence, that's just a 1, right? So I'll show you both ways. The way I do it, I need M's. I have 2 M's to choose from, then 1 left over, then 9 factorial for the remaining letters. Then I divide out my repeats. Same as that one. 2 factorial, 2 factorial, 2 factorial. Okay? This 2 factorial is for the M's. So essentially that simplifies to 9 factorial over 2 factorial, 2 factorial. Okay? So, the other way, and there, only one way. You'll only have 2 M's, and they've got to be in those positions, so I've used them up. Now, here is my 9 factorial for everything else. What's repeated in those 9 remaining letters? Only the T's and the A's. So that ends up simplifying to the same thing here. Okay? So again, how you think about it, whatever is easiest for you. This way keeps the total number of repeats in the denominator, but again, up to you. So vowels together, another question. So how many vowels are there? So 1, 2, 3, 4 vowels. Okay, consonants would be 7. This would be the answer if they were all different and started with vowels. Okay, they're not all different. So, and it says just anywhere. Vowels that must be kept together. So remember, this could be at the beginning, or it could be after the first consonant, or after the second, or after the third. Basically, we're arranging the group of vowels and the consonants, so that would be 8 factorial. Got to divide, though, by the repeats. So, got to divide that by the repeats. Okay? So So vowels together at the start, then consonants, and then this 8 gets the arrangement so that the vowels are anywhere together, and then I repeat. Okay? I guess you could go, okay, for the vowels there's a repeated A, so that too could go with this, and then the consonants, but it's the same deal, right? If you divide by 2 times 2 times 2, it's the same as this divided by 2, this divided by 2.
So like, what would you accept for an answer to this? Like, because you can simplify it.
That one I'd probably ask for that.
No.
Okay, so now we're back to that kind of question. No two vowels can be together. Okay? Because we have 4 vowels in this case. Okay, so they can't be together. So we want to, if there's 4 vowels, there's 7 consonants. So 1, 2, 3, 4, 5, 6, 7 over there. So these are consonants. So that's going to be 7 factorial, right, for the consonants. Again, let's assume that there's no repeats to start. So those are the consonants, and then the vowels cannot be together. So we could have a vowel there. So think about, they have to go in between a consonant, or before or after. So I'll use arrows to just show in between there. Okay. Now there's only 4. Okay, so there's not more than the number of spaces. So we're taking now the spaces there and filling it up with the 4 vowels. So 1, 2, 3, 4, 5, 6, 7, 8 spaces to put the 4 vowels, okay, would be for that part, and then we have our 7 consonants. Oh, 7, keep 7, not C for consonants. Okay, and then we have to figure out the repeats, right? So then you want to divide by your 2 factorial, 2 factorial, 2 factorial. Okay, so you're taking the spaces there, right? So you can do it a shorter version. This is kind of like Jasper. Yesterday we did Jasper, and we had to split up, I think, the vowels as well. But if you have 4 vowels, 1 could go there, 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 there. That would be one possibility. You could go here, 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 here. But you can't put 2 vowels in between, right? So you have to put them where these arrows are. They cannot go anywhere else, because they have to be between or before a consonant. So you have 8 places to put 4 vowels in. So you're just arranging those places. If you choose any of those places, you're good. You're not going to be repeating. You're not going to be having vowels together. Okay. So saying that, let's go back and see if that helps with the one that we left. This one? Yeah. So now, no 2 vowels together. Okay. Right, so I put, what was the word? Logarithm. Yeah, so I put the vowel, so let's just hopefully use pencil. Let's just erase that. Put the consonants. So 1, 2, 3. So we got 1, 2, 3, 4, 5, 6. So these are our consonants. Okay. So that's going to be 6 factorial for those. And then, so no two vowels together, so we would have to have a vowel either there, there. Okay. So how many possible places for that? 1, 2, 3, 4, 5, 6, 7. So that's 6 factorial, and then 7 p, and then there are 3 vowels.
Yeah, but
Right, and then let's actually, well, you can calculate it that if you want. But so these are the consonants. We have just 3 vowels. So the first vowel could go here. Any of these positions, but you can't have more than one. You can't put 2 vowels there. So if and the good thing here, well, in all of these, the number of places that you can put a vowel is more than the number of vowels available, right? So that would be a more challenging question if you're doing it for a smaller number of objects, but we're using all of them here. Okay.
and what if like the vowels? Well, that would just be arrangement.
Vowels all together would be here.
No, vowels like if it's just anything. Or what about like something like at least 2 vowels must be there?
Then you have to do the 2 cases. 2 together with 3 together.
But how do we figure that out?
2 together. You know how to do 2 together.
No, like, no, it's like, oh, yeah, that's right.
And then, okay, so we're running short of time, but we did get through to number, oh, that's not numbered correctly, is it? 17 to 20? Okay, 17 and then 20. Not sure what happened there. Sometimes Word doesn't really fit. In any case,
What about other ones, like, the one where it's like, oh, it's two, like, it's like, you got 2 possibilities, like, you have how many vowels, and then 2 times spots, and then add that to the
okay, so I'll leave that one for you to do. Exercises here. Then just I want to give you just a heads up on the. Oh, I thought I opened the back way, so just 1 second.
Oh, gosh.
Okay, so halfway problems. First 3 are very basic, just like the ones we did. Okay? Then, a little bit more complicated in questions 4 and onwards. Get my smartphone a little bit here. Okay, so in this one, if you're supposed to go from A to B, passing through C, you can't go in this part of your diagram, okay? Because you have to get to C and you always have to get closer. So this, you have to figure out how many ways to get from A to C, and then how many ways to get from B to C. Okay? So from A to C, well, you can count this up if you want to, but if you do it the long way, this is going to be 3 factorial over 1 factorial, 2 factorial, right? Which is just 3 ways. Here, That's what we just did. That was 10 ways. Okay? Do you think we add 10 and 3, or do we multiply 10 and 3?
Multiply because it's an and.
For each of these ways, you have 10 possible ways here. So it's kind of like a tree diagram. So for each of these 3, we have 10. So that's multiplication. Okay, so for the first way to get to C, there's 10 ways to get to B. For the next way to get there, there's 10. And the third way, there's 10. So when it's split up like that, same thing here, you have to go through C. So there are your 2 rectangles. Find the pathways for each part and multiply them together. Okay. What about this one? How many ways to get from A to C? 1. A straight line. And then just 3 there. So that answer would be 3. Don't even have to think about it. Okay. This is nice because it doesn't have all the other stuff. The only way you can get to B is by getting to each of these corners. So you have to go from A to that corner, from that corner to that corner to that. Again, multiplying them together. And then challenge question number 8. Okay, you're going from the mall to the airport. Can't swim through the lake. Got to go through B. So here's your rectangle. But this is not a rectangle. So you're going to have to think about how to get from B to the airport. So you might do it that long way that I showed you with the corners. Okay, so I'll leave that for you to do. Okay, and then for more 9 and 10 together. Challenge. We'll talk about more of those later. Okay.